More stuff on a circle. Okay, a circle always has a center. And if you were to draw two radii.
I'm sorry. Please.
So I got radius AB and radius AC. That forms what inside the circle? An angle.
Wow.
Okay? That's a central angle. A central angle is the vertex is the center. Okay? Now, just to jump ahead a little bit,
You're very unique.
there's two types of angles. There's a central angle and there's an inscribed angle. So the difference is the inscribed angle has the vertex on the, and the central's in the center. Okay?
Makes sense.
So, today's is just identifying these. It's pretty easy. Minor arcs and major arcs. A minor arc is less than 180. And a major arc is greater than 180. And obviously, people know what a semicircle is? 180 degrees, half a circle. Okay? So, if I put some points on here, I'll just go like that. The minor arcs on this circle right here, the way you label arc is you just put a little arc above it. From B to C is less than 180, so that's a minor arc. Okay? C to D is minor. How about B to D?
Depends on which way you go.
Depends on which way you go. I should have another point on here actually to make it. Okay, so if this is the thing with arcs, if I put only two letters means you take the shortest route. Okay, so if it's just BD, this way takes longer than this way. Okay, so minor arcs only use two letters. Okay, a major arcs uses three letters. Even though arc BCD, I mean start at B, go through C, and end at D, it's the same exact arc as that. It's just since it's a minor, you only use two letters. Okay? Because it's the shortest way. So a major arc then is, say I'm starting at B and going this way. You could call that either BCE or BDE. They're both the same arc. Any letter in between you can pick. So it's just directions. It means start at B, go towards C, and stop at E. Okay? So when they're saying arc BE, since there's only two letters, that's the shortest route. So that would be this way. So part of it is just looking at the picture and saying whether it's major or minor. Is that easy enough? Okay. A semicircle, I didn't draw it in here, but if we had a diameter, EF, arc FB would be a semicircle. You don't need to put other letters in there because from F to B, no matter which way you go, it's 180. Okay, unless you want to describe which way to go. A semicircle could use three. You could call it, if we're talking about this side, you'd call it FEB. If you're talking about this side, it's FDB or FCB. Okay? Congruent arcs is just what it sounds like. Everyone knows what congruent means, right?
Yeah.
Equal arcs. All right. So this angle or arc addition postulate is just like way back in chapter 2, I think it was, We did the segment addition postulate, and all that says is if you take a small segment and add on another segment to it, AB plus BC equals the whole thing, AC. This plus this equals the whole thing. Then we did the angle addition. Angle ABC plus CBD equals angle ABD. All these addition postulates say if you add things together, it gets bigger. So arc AC plus CB is arc ABC. Oh, I went the wrong way. Yeah. AB plus, you could leave it CB or BC, it doesn't matter, is arc ABC. This plus that equals the whole thing. Just the common sense, that's why they call it postulates. Postulates are things that just make sense. All right, when you're doing these, which we do a lot of these, like on worksheets and tests and stuff, the thing you want to do is just fill in all the unknowns. Now, I didn't show you yet, but if you've got a central angle, I'm just going to make a 90-degree angle right there. Okay? How many degrees of this circle?
90.
It's 90. It's a fourth of the way around, right? And 1/4 of 360. Okay? So what this means is a central angle and its arc are always going to be the same.
Okay. So the GF is 70.
Yep. So GF doesn't ask here, but yeah, GF is 70. It doesn't matter, you know, like if I have a 70-degree angle, it doesn't matter if I draw a circle this big or a circle this big or a bigger circle. Yep, this will be 70 degrees because it's still 70 out of the 360. This will still be 70 degrees. So no matter how big the circle is, it's always the same as its central angle. Okay, so DG, since it's only 2 letters, you take the shortest route. So that arc is?
Oh, 80 plus 70 is 150?
150. Because this is 70, that's 80. DGH means start at D, go towards G, and end at H. So that's 150 and 120 is 270. And then DH, we don't know, but we can figure it out because this has to add up to 360. We just figured out it's 270, so this has to be 90. Okay, so central angles and arcs that they intersect are the same. Yep. Other than this. Chords. If you've got 2 chords that are the same length, then the arcs will be the same also, same degrees. Okay? So if you saw that this was 10, that means this is 10. If this is 110 degrees, that one's also 110 degrees. Okay? If you've got a diameter that's perpendicular to a chord, 2 things happen. It's going to bisect this, so this piece equals that, and this chord or this arc is going to equal that arc. It cuts that arc in half. So if you saw this picture and they told you this length was 4 and this was 40 degrees, that means this would also be 4 and that would be 40 degrees. Okay? This is just the opposite of this. If you know that this chord right here is perpendicular to this chord, then you know that this is a diameter. Okay? Now these properties, oh, there's one more. If two chords are the same distance from the center, how do you suppose they compare to each other?
They're the same.
Same length, yep. Okay, now these properties here, and this is one of the problems we're not gonna have to do, but it is in your book. You guys have heard of when people go skiing in the mountains, they gotta wear the beepers in case they get caught in an avalanche?
Yeah. Oh, yeah.
It's maybe changed a little bit now since this book was made, but this is what it used to be. If they got buried, it sent out a beep the same distance, so it would send out the sounds reaching out in a circle, because it would send out a beep or whatever, you know what I mean? So this is what they would have to used to do. Nowadays, I'd imagine they got a GPS where they could go right to them. But people would be walking around holding their receiver, and as they're walking, as soon as they'd hit a beep, they'd put a flag right there, and then they'd keep walking, and when it stops, they'd put a flag there. They'd measure this, go to the center, and then they'd have to walk at about a 90. So they'd walk till it beeps, go back, walk till it beeps, and then they'd measure that, and right in the middle would be the center of the circle, which is where the beacon would be coming from. So that's how they would locate them.
So you could like walk right on top of them.
Yeah, you would walk right over them, but you wouldn't be able to tell till after you measured.
I feel like they should have just made it like be louder. Detectors.
Yeah, you'd think so. Okay, so most of these problems, things are just equal to each other. If you're not sure what to do and have to guess that they're equal. Look what they look like. Like here, in order to figure out what x is, what do you know about this degree and that degree?
They're equal to each
They're
other.
equal because it's a diameter that's perpendicular. So 5x equals 7x minus 16. Subtract 7x. 2x equals, so negative 2x. Divide by negative 2 and you get 8. Okay. All right, in this one, they don't have all the measurements on here. Find QS if MN is 16, which means what's this and what's that? 8 and 8. And NQ is 10. They have that one in there. Now, since they're perpendicular, and does it say if they're equal? Oh yeah, right here. It says RT is also 16. What that means is this distance and this distance will be the same, right?
Mm-hmm.
So if we could find this one, it'd be the same. Any idea how we can find what x is? Thinking back to what we just did last chapter. Pythagorean theorem. It forms a right triangle. You know two sides, so use the Pythagorean theorem. 10 squared minus 8 squared. Square root of it is 6.
So easy.
Okay, so here they're equal. And in your assignment, they're as easy as this. Sometimes they'll say this is 7 and that's x. So what's x? 7. Okay? We already know how to do that one. You just set them equal to each other and solve it. Just to point it out, this one they don't want x, they want the measure of the arc. So you'd have to find x. So subtract 3x, divide by 4, and you get 6. So when we plug it in, this is 42, which means this one's 42. So the measure of the arc is 84. 42 and 42. This one's the Pythagorean theorem one. DG and JL are both 24, which means this is 12, and that's 12, and that's 12, and that's 12. DH is 13.
13.
So we want to find HK, which means if we find that, we solve it.
13 squared minus 12 squared.
So you subtract them because you're looking for a leg, and that is 5, I think. Yep. Okay.